Welcome to Carlton's Math Corner. Today we are going to study the Pythagorean theorem. At this time, please make sure you have your math journal, vocab packet, as well as something to write with. Before we get started, we are going to need to record some vocab words because we're going to be working with right triangles, and so we need to learn the different parts of the right triangle. The shortest sides on a right triangle, so these green highlighted sides, those are called legs. And the longest side that connects those legs is called a hypotenuse. And it's always the opposite of the right angle. Then we are going to learn the Pythagorean theorem, and this probably doesn't even make sense to you right now, but Pythagorean theorem is basically used to find a missing side on a right triangle. Okay, and so we are going to use this formula in order to find that missing angle. And we're going to learn about that formula in just a moment. Okay, and then we're going to talk about what is a Pythagorean triple, and we are looking for counting numbers that fit the formula, and we'll talk about what that is in the future. So either in this video or in another video on the Pythagorean theorem. Okay, so let's get started. Our first target is I can find the hypotenuse of a right triangle. So first of all, here's a diagram again of the different parts of a right triangle. So we have the legs. We call this leg A, leg B, and these two really can be changed. They don't have to be, this doesn't have to be A and this has to be B. They can be swapped, okay? The hypotenuse, though, cannot be. It has to be the one that's straight across from the right angle, and we call that C. So this one has to be C, but these two can switch if they want to, okay? What I want you to look at is, I want you to make some observations about this diagram. First of all, what do you notice about the areas of the squares? How about the triangle in the middle? What are the lengths of each side of the triangle? And how are the lengths, and that's a T, how are the lengths of the sides related to the squares? Okay, and so let's start off with just the first question. What's the area in every square? So what's the area in this square? Well, we have 5 times 5, so 25. How about the area of the square? 9. How about here? 4 times 4 is 16. What do you notice about these areas? Do you know, well, here's what I notice. I notice that if I add 16 plus 9, I get 25. And if I do 25 minus 9, I get 16. Or 25 minus 16, I get 9. That's what I notice. Okay? Now, looking at the triangle in here, what are the side lengths? Well, the side length here is 5. And let's move that over there. So the side length of this one is 5. The side length of this one is 3. And the side length of this one is 4. How are the lengths of the sides related to the squares? Yeah! Did you know that if I take this 3 and I square it, if I take that 3 and I square it, do I get 9? Yes. What about this 4? If I take this 4 and I square it, do I get 16? Absolutely. If I take this 5 and I square it, will I also get 25? Yes. Nice job. And actually, this diagram shows us the Pythagorean theorem. So here's the Pythagorean theorem. I know we've already written it down, but I want you to see it again. So here's the right triangle in the center. If I take this side and I square it, and this side of the triangle and square it, if I add those two together, I should automatically get the area of the last side. And then, what is the opposite of squaring something? Yes, square root. If I take the square root of something, I should be able to get down to figuring out what the length of this side is of the hypotenuse. Okay, so let's look at a problem and see what I mean by that. So here's our problem. So here is a right triangle. We are missing the hypotenuse and we're trying to find that value. What steps do you notice? Well, I noticed that we know the 8 and we know the 15. So we could call that A and B, or A and B, however you want to say it. But we know that those are the lengths of the triangle. So if I go back to what we just saw, as an illustration, if I take that 8 and I square it, and I take the 15 and square it, shouldn't I get the number? Shouldn't I get what the squared part is of this hypotenuse? Yes, I should, because if I add those together, I should get that. So let's do that. 8 squared is 64. 15 squared is 225. If I add them together, I get 289. Now, there is no way that this hypotenuse is 289 units. There's no way. That's too big. So, especially when these are only 8 and 15. So now I'm trying to figure out what times what is 289. And remember when I asked you what's the opposite of squaring something? The opposite is square root. So if I take the square root of it, I should get the answer. So if I take the square root of 289, here's what I get. 17. Now, square root of 80 or 289, there's actually two answers because positive 17 times positive 17 is 289, but also negative 17 and times negative 17 is also 289. But when we're working with the Pythagorean theorem, we are trying to find distance from this point to this point. When we're working with distance, you don't work with a negative number. You work with a positive number because I don't travel a negative distance. And so we only select the positive answer. So the square root of 289 is 17, and that would be my missing hypotenuse. Okay, so here's what we did. We basically squared each leg and then we made it equal to the hypotenuse. And from there we found the sum of the legs. We added them together and then took the square root to find the hypotenuse. Okay? So I would like you to try these 4 problems. Please make sure that you're showing your work steps. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.